America just responded to China's flying car, and the response is not what most people expected. It is not a press release announcing that American engineers are working on something similar. It is not a congressional hearing about the threat of Chinese aviation technology. It is not a tariff or a trade restriction or a regulatory barrier designed to slow China's momentum while America figures out what to do. The response is a real vehicle with real engineering behind it, real test flights already completed, real certification progress already made, and a real timeline for commercial operation that is closer than the public conversation suggests. And it is not the only one. Because while China has been building its flying vehicle ecosystem with the full weight of government backing and industrial policy, America and its allies have been doing something that gets considerably less attention but carries considerably more long-term significance. They have been building the intelligence layer. The part of the flying vehicle revolution that is not about how cheap the vehicle is or how quickly the factory can produce it. The part that is about what the vehicle can actually do when it encounters a situation nobody planned for. The part that determines whether a flying vehicle is a sophisticated machine that performs well under controlled conditions or a genuinely autonomous system that can be trusted to operate safely across the full range of real world. Situations that real-world operation inevitably produces. Today we are going through the honest global competition, not the version where one side is obviously winning and the other is obviously losing. The version where each side has genuine advantages in the dimensions it has invested in most seriously. Where the competition is real, the stakes are significant, and the outcome is genuinely uncertain in ways that the loudest voices on both sides of this story prefer not to acknowledge. By the time we finish, you will understand where America genuinely leads, where China genuinely leads, where the gap between them is closing, and where it is not. And you will understand why the country that wins this race will probably win it in a dimension that most current coverage is not focused on. Hit the like button right now before we go any further. Research at this depth takes serious time, and every like directly helps this reach people who want the honest picture rather than the partisan one. Subscribe and turn on notifications. This story is more interesting than either side's promotional materials suggest. Let us get into it. Start with what America has actually built, because the narrative that Western flying vehicle development has failed is not accurate and the evidence does not support it. Joby Aviation has been developing an electric vertical takeoff and landing aircraft since 2009. 15 years of engineering work, over 17,000 test flights completed. A vehicle that has demonstrated a range of over 100 miles on a single charge at speeds exceeding 200 miles per hour. FAA certification progress that has moved further than any other electric vertical takeoff and landing company in the American market. A partnership with Delta Airlines that provides both funding and a defined commercial deployment pathway, and a manufacturing facility in Marina, California that is already producing pre-production units. Joby's vehicle looks different from the Chinese autonomous pods that most of the public coverage focuses on. It has a pilot, a human being sitting in the cockpit making decisions. That is not a limitation of Joby's technology. It is a deliberate choice reflecting a specific understanding of where the American market is and what American regulators will certify in the near term. The FAA will certify a piloted electric vertical takeoff and landing aircraft operating under existing pilot certification requirements before it will certify a fully autonomous passenger aircraft with no human operator on board. Joby made the engineering and commercial decision to target the certification that is achievable on a near-term timeline rather than the certification that represents the ultimate vision of the technology. That is not a failure of ambition. It is a sophisticated reading of the regulatory environment that determines what can actually reach commercial operation and when. Archer Aviation is on a parallel track with a vehicle called Midnight. 4 passenger seats, a pilot, a range and speed profile suited to urban and regional air taxi operations. Manufacturing partnerships with Stellantis, one of the world's largest automotive manufacturers, providing the production scale capability that aerospace startups historically struggle to access. United Airlines has placed an order for up to 200 vehicles. American Airlines has placed an order for up to 250. These are not letters of intent from companies that are being polite to a startup. These are purchase commitments from major airlines that have run the economics of electric air taxi operations and concluded that the business case is real at the price and performance specifications Archer is targeting. Whisk Aero is taking the fully autonomous approach. No pilot, no controls, a passenger experience closer to the Chinese model of sitting in a pod and arriving somewhere without any human intervention in the flight. Whisk is a joint venture between Boeing and Kitty Hawk, and it has completed thousands of test flights in New Zealand and the United States. Its timeline to commercial certification is longer than Joby's or Archer's because the regulatory pathway for fully autonomous passenger flight in American airspace does not yet exist in its final form. But the engineering work is serious, and the backing is from companies that understand aerospace certification at the deepest level. Lilium filed for bankruptcy in 2024. That is a fact, and it belongs in any honest account of Western flying vehicle development. But Lilium's bankruptcy was not evidence that the technology was unachievable. It was evidence that a specific business model, high capital intensity development of a jet-powered eVTOL at a startup that could not reach the production scale required to bring costs down before running out of runway, was not financially viable at the timeline Lilium was attempting. The technology Lilium developed did not disappear with the company. The engineering insights, the patents, the talent, all of it continued in the industry. Now Boston Dynamics. Because any honest account of the competition between American and Chinese flying vehicle technology has to include what America has built in the intelligence layer that the vehicles sit on top of. Boston Dynamics has spent decades building robotic systems with movement capability that no other company in the world has matched. The dynamic balance systems, the real-time response to unexpected physical disturbances, the ability to operate in environments that were not specifically prepared for robotic operation. These are not capabilities that are primarily visible in flying vehicle applications. They are capabilities that reflect the deepest level of what autonomous systems need to do to function reliably in the real world. The relevance to flying vehicles is not direct. Boston Dynamics is not building aircraft. The relevance is to the intelligence layer. The software systems, the sensor processing, the real-time decision-making, the response to novel situations that were not in the training data, that make the difference between an autonomous system that performs well in controlled conditions and one that performs reliably across the full range of conditions real-world operation produces. American investment in this intelligence layer, across Boston Dynamics, across the university research programs that produce the founders of every major American robotics and autonomous systems company, across the defense research programs that have been developing autonomous systems for military applications for decades, has produced a depth of capability in this specific dimension that China is working hard to match and has not yet fully matched. The flying vehicle that wins the long-term competition is not the one that is cheapest to produce at current technology. It is the one that can be trusted to operate safely in the widest range of real-world conditions without human oversight. That vehicle requires the intelligence layer more than it requires the manufacturing cost structure. And in the intelligence layer, the competition is considerably closer than the vehicle price comparison suggests. Now the honest assessment of where China genuinely leads, because this is not a story where one side is right about everything. China leads in production scale. The 30-plus companies simultaneously developing flying vehicles, the manufacturing ecosystem built on electric vehicle supply chains, the cost compression that has brought personal flying vehicle prices to levels that Western manufacturers cannot currently approach. All of this is real and significant. The $4,937 vehicle exists. The 5,000 pre-orders for the Xpeng land aircraft carrier exist. The factory with 10,000 unit annual capacity exists. China leads in deployment scale. Over 300 EHang units in commercial operation generating real flight hours with real passengers. Air corridor infrastructure already built and operating in multiple cities. A regulatory framework that certified autonomous passenger aircraft for commercial operation years before equivalent certification is available in Western markets. The operational experience that comes from actually flying passengers rather than accumulating test hours in controlled environments. China leads in infrastructure development speed. The decision to build the infrastructure alongside the vehicles rather than after them has produced a head start in the landing pad networks, the air corridor designations, the ground control systems, and the regulatory frameworks that constitute the ecosystem supporting the vehicles. Infrastructure that took China years to build will take other markets years to build, regardless of how quickly the vehicles themselves develop. China leads in government alignment. The designation of low-altitude aviation as a national economic priority with coordinated policy support, industrial funding, and regulatory development has produced an environment where the obstacles that slow flying vehicle development in other markets, regulatory uncertainty, infrastructure investment decisions, supply chain development, are addressed through deliberate policy action rather than market evolution. The speed advantage this provides is real and substantial. These are genuine advantages. They are not going away on a short timeline, and any honest account of where the competition stands has to start by acknowledging them fully. Here is where the competition gets genuinely interesting and where the outcome becomes genuinely uncertain. The autonomous intelligence capability, the ability of a flying vehicle to operate safely and reliably across the full range of real-world conditions without human oversight or hidden human assistance, is where the competition is most closely contested and where the long-term winner will most likely be determined. China's flying vehicle demonstrations have been impressive. The EHang EH216S carrying passengers on certified commercial routes is a genuine achievement. The operational data from over 300 units in commercial service is genuinely valuable. The ground control infrastructure managing these flights is genuinely sophisticated. But the ground control model, where human operators on the ground are monitoring every flight and have intervention capability, is a different thing from genuine autonomous operation at scale. At 300 units in service, with relatively constrained routes in conditions that have been carefully characterized, ground control oversight of every flight is manageable. At 100,000 units in service, operating across dense urban airspace on routes that span the full complexity of urban environments, ground control oversight of every flight is not manageable in the same way. The transition from ground-monitored autonomous flight to genuinely autonomous flight at scale requires the kind of intelligence layer development that American investment has been most focused on. The ability of the vehicle AI to handle novel situations without ground control intervention, to make the kind of judgment calls that current systems escalate to human operators, to operate safely in conditions that were not specifically anticipated during development. This is the capability that Joby, Archer, and Whisk are building toward. Not just a vehicle that can follow a pre-planned route under favorable conditions with human backup available. A system that can be trusted to operate safely across the full range of conditions that real-world operation produces at the scale that mass adoption requires. The military dimension of this competition deserves specific attention because it is where the stakes extend beyond the civilian transportation market and where the competition between American and Chinese development carries implications that go well beyond who sells more air taxis. The same capabilities that make an autonomous flying vehicle useful for civilian transportation make it useful for military logistics, reconnaissance, personnel movement, and resupply in contested environments. The Pentagon has been funding development of autonomous air mobility systems for military applications for years. The investment is not primarily in the vehicles. It is in the intelligence layer that makes autonomous vehicles trustworthy in environments where the consequences of failure are not a delayed delivery or an inconvenienced passenger. The asymmetric security implications of low-cost autonomous flying vehicles are significant in both directions. A cheap, widely available autonomous flying vehicle that can carry a payload through low-altitude airspace that existing defense systems were not designed to monitor at that flight profile is a security challenge regardless of who operates it. The detection, identification, and response to this category of threat is a problem that defense establishments are working on but have not fully solved. China's deployment of autonomous flying vehicles at scale creates a detection and response challenge for potential adversaries that the scale of deployment amplifies. 100,000 autonomous flying vehicles operating over Chinese cities creates an air traffic environment that adversarial systems attempting to operate in that environment have to navigate or avoid. The civilian infrastructure serves as a form of area denial by density that was not a feature of conventional aviation. America is aware of this. The military dimensions of autonomous flying vehicle technology are being worked through in detail in contexts that do not appear in public reporting. The civilian competition between American and Chinese flying vehicle development is happening in parallel with a military technology competition in the same domain that is equally significant and considerably less visible. Now Japan, because the competition is not simply bilateral, and the most revealing data point about where international flying vehicle development stands did not come from China or America. When Autoflight's Prosperity eVTOL completed demonstration flights connecting 3 Japanese islands, something significant happened. Japan's regulators did not respond with caution, with demands for additional safety demonstration, or with the kind of regulatory hesitation that has characterized the Western response to autonomous flying vehicle technology in most markets. They responded with interest. Japanese islands with aging coastal infrastructure and no affordable road or ferry alternative saw in the autonomous flying vehicle a solution to a transportation problem that conventional infrastructure could not solve cheaply or quickly. The regulatory response reflected a transportation need assessment rather than a precautionary technology assessment. This is the pattern that is emerging across the markets where flying vehicle adoption is moving fastest outside China, not the wealthiest markets, not the markets with the most sophisticated aviation infrastructure. The markets with specific transportation problems that existing infrastructure cannot solve, and that autonomous flying vehicles can address at a cost and timeline that conventional alternatives cannot match. Islands, mountain regions, aging road networks, sprawling cities where the cost of new rail infrastructure is prohibitive. These are the markets where the regulatory maze clears fastest because the need is clearest. And these are the markets where the operational experience that makes the technology trustworthy at scale will accumulate fastest. Here is the honest synthesis of where the competition stands. China leads in production scale, deployment scale, infrastructure development, and the speed advantage that government alignment provides. These are real advantages that translate to real operational experience that is making Chinese flying vehicle systems better faster than systems that are not yet operating at comparable scale. America and its allies lead in the intelligence layer, in the dynamic, autonomous capability that determines what a flying vehicle can do in conditions nobody planned for, and in the regulatory rigor that, while slower, produces certification standards that will be more widely accepted internationally than certifications produced by a regulatory process that prioritizes speed. The competition is real on both sides, the outcome is genuinely uncertain, and the dimension in which it will ultimately be decided, the autonomous intelligence capability that allows vehicles to operate safely at scale without human oversight, is the dimension where the investment gap between the two sides is smallest and where the lead changes hands, most frequently as development progresses. The vehicle that wins this race will not win it because it was cheapest to produce or because it was first to carry a passenger. It will win it because it can be trusted to carry a passenger safely in conditions that nobody anticipated, at a scale that no ground control system can manage individually, across a network that no regulatory framework has fully anticipated. That vehicle does not yet exist on either side. Both sides are building toward it, and the race to get there is the most consequential technology competition of the current decade. America responded to China's flying car. The response is serious, technically sophisticated, and aimed at a dimension of the competition that the price comparison alone does not capture. Whether it is fast enough is the question that the next 5 years will answer. If this gave you a more complete and more honest picture of where the global flying car competition actually stands, hit the like button. It genuinely helps this reach people who want the full story rather than the version that fits a simple narrative. Subscribe and turn on notifications because this competition is producing new developments every month and we will be there when the significant ones break. Drop a comment and tell me honestly, after seeing both sides of this, which country do you think gets to genuinely autonomous flying vehicles first? I read every single one. See you in the next one.